The first thing we're going to work on is we're going to talk about the four goals of science. These goals help us to understand why we conduct different kinds of science. Probably the very last one will be the one that is most familiar and that's easiest for you to understand, but the first three actually form the foundation about why science progresses. Next, we're going to distinguish between frequency, association, and causal claims, and there's an assignment you're going to do related to that. And then we're going to analyze construct, statistical, external, and internal validity. The first goal of science is description. This is to try to establish broad generalizations about a population of individuals or organisms. Description in science actually follows the nomothetic approach. I know that's a mouthful. The nomothetic approach is where you try to make broad generalizations about the largest, most diverse population. The problem, of course, is with the descriptive nomothetic approach that these descriptions will not apply to everybody in a population. For example, if I'm really interested in understanding couples who are married and their experiences they have while married, that understanding the conclusions I come to for heterosexual or straight couples may in some ways be similar to the conclusions I may reach for gay, lesbian, or other same-sex couples. But in fact, there may be things that are different about same-sex couples and their relationships that are different from heterosexual or sometimes what we call straight couples. One of the things you need to establish in a descriptive method is high external validity. External validity tells you how well your results can be generalized to other groups, settings, or situations. So this is one of the major kinds of validity that we're going to talk about, one of the four in this course. Oftentimes, descriptive studies try to make frequency claims where they're trying to describe a particular rate or degree of a single variable. So if my goal is to understand how many college students or what percent of college students have depression or anxiety, that would be a frequency claim that I'm trying to understand. And I know that if I have really good external validity, that would be because I collected data from college students who are in two-year colleges and four-year colleges and public colleges and private colleges, from first-year students, second-year students, third and fourth-year students, from brand new students coming out of college, coming out of high school, or returning students who are returning to college after working in a field for a particular amount of time. Right? So good external validity happens because you can generalize because you've done a good job of collecting your data. We're going to talk more about external validity when we get to chapter 7, and we'll talk a little bit more about frequency claims today. Okay. The second goal of science is prediction. This is where we try to examine the relationship between two or more variables, and prediction studies often try to make association claims. Association claims say that there is a relationship between two variables. We can sometimes say that these variables are associated, or they covary, or even that they correlate together. Okay, but generally we're going to call those predictive studies or prediction studies, and they're often trying to make claims about the relationship between two variables. For example, you may have heard that if you go to college, you're going to make more money than people who don't go to college. And if you go to a little bit of college versus a bachelor's degree, or you go to even beyond a bachelor's degree and you get a graduate degree, maybe you've been told that there's more income associated with that. Similarly, maybe you've been told that the more you exercise, the more weight you're going to lose. Or maybe you've just come to believe that. Third, maybe you believe that the more you study, the higher your grades are going to get. But in fact, one of the problems with prediction studies or association claims is that you never really know whether one variable is causing a change in the other variable. So is it true that studying more actually increases your grade, that it causes a change in your grade? Is it true that exercising actually causes you to lose weight? Is it true that more education, more years of education actually does cause your income to go up? Well, what are some alternative explanations, right? What are some other ways we might think about what's causing these changes? We sometimes call these third variable problems, where there's another variable maybe that's causing a change that's not any of the ones that you looked at in your study. So maybe it's not that education level increases your income. Maybe it's that people who have the ability to gain more years of education come from wealthier families, and wealthier families allow you to get opportunities to get better jobs. So maybe it's not that more years of education increases your income. Maybe it's that more family wealth increases your income and also happens to increase the level of education your family can afford. Maybe it's not that exercise causes weight loss, but maybe there's other things you're doing in addition to exercising, like changes in your diet that are correlated with weight loss or causing changes in weight loss. Third, you can imagine lots of cases where you could have ineffective study strategies, and that does not increase your grades. So there are lots of other things that could increase your grades. So access to tutors, how focused you are when you study. So there are lots of cases where we can see clear examples where there is not a link between correlation and causation. For example, here's a correlation between how much the U.S. spends in billions of dollars per year on science, space, and technology, and this goes from 1999 all the way through 2009. So the red line is the amount of money we're spending on science, space, and technology, and in fact, it is correlated with the number of suicides by hanging, strangulation, and suffocation, which is here in the same years in black. If you remember talking about correlation coefficients in your stats class, this is the R value, which is 0.99789. That's about as close to 1 as you can get. So that suggests a really high correlation. But I would guarantee you that there's no causal relationship there, right? That it's highly unlikely that the more we spend on science, space, and technology, that the more people are actually hurting themselves through these methods. Similarly, and more amusing, here's the correlation between the number of people who drowned by falling in a pool and the films that Nicolas Cage appeared in that year from, again, 1999. 2009, the correlation is not as strong. You can see the lines are not as close together, but the correlation value is still, the R value is 0.666. So, right, the more films Nicolas Cage is in appears to be correlated, but likely not causal with the number of people who fall and drown in a pool. Here's another one, and you can look at, there's a link in Canvas, so you can take a look at the rest of these. This is the amount of cheese consumed per person, so it's around 30 pounds per year, by the way. And then there's the number of people who died by becoming tangled in their bed sheets. Again, right, these are spurious correlations. They're not true, so be careful about the conclusions you come to in these cause and effect relationships. Okay. There are generally three kinds of association claims we find: positive correlations, negative correlations, and no correlation. Positive correlations is when the two variables change in the same direction. Negative correlations, they go in opposite directions. And then, of course, no correlation would mean they're not related at all, right? That as one variable changes, nothing consistently happens to another one.
So let's go ahead and talk about the remaining two goals of science, the third and the fourth goals. The third goal of science, as you can see on the slide, is explanation. That one variable we can determine is causing a change in another variable. These are the kinds of studies you often are familiar with. These are the kinds of questions you often have about how the world works. What causes, for example, your mood to change related to weather? When it's a sunny day and you feel happier, more energetic, more likely you want to go outside and exercise or go for a hike, is that because sunlight is somehow causing some change because of a physiological process? That claim is a causal claim, that we believe that rainy days or sunny days or sunlight in particular are causing a change in some variable we're interested in. Classically, we measure causal claims by doing experiments. The only way we can determine if something is a causal claim is by doing an experiment where we've altered a situation in a specific way to induce either a psychological or a physiological change. So if I want to know if the sunlight changes your mood, I need to expose you to light that, let's say, mimics sunlight, but not tell you that that's what it's doing, and see if it actually does have some change on your behavior. And in fact, I have to have removed any other possible explanation, that it's not because it's summertime and you have more free time to go out and explore. It's summertime is coming, and so you feel the need to be exercising more. There are two kinds of variables that are used in an experiment that we're going to talk about now. There are a few others we're going to add later, but for now, what I want you to know is the difference between an independent variable, sometimes also called a causal variable, or a manipulated variable, and a dependent variable, sometimes also called a measured variable. So an independent variable is the part of the system or the organism or the environment that we manipulate or alter. So in my study about sunlight and mood, then the independent variable should be the sunlight that's changed, and the dependent variable then would be, right, the change in your mood if it happens. The dependent variable is the measurement of the behavior, the thought, the feeling, or maybe even the physiological functioning that we think is being altered or caused to change because of the independent variable. So that should give you a little bit of an introduction. I'm going to ask you throughout this course to be able to identify independent and dependent variables. These are the ones that students often struggle with the most at this level. I promise you it will get easier, but when you look at a study, independent variables are often the ones that have been manipulated in the study where the researcher has changed it, the amount of drug you're given, the amount of sunlight you're exposed to, a particular kind of therapy you go to, any of those where we randomly assign participants to different conditions. Some people get to drink diet beverages and others drink regular sugared beverages. Or I want to compare, maybe you heard the study about full fat milk and non-fat milk, and actually multiple studies are showing that full fat milk is better for you. Yeah, right, interestingly enough, reduces the rates of obesity, reduces the rate of heart disease. So actually fat may be good for you, which is funny because in the 90s we went into this sort of like, we don't eat fat at all, right? So everything was non-fat or low fat, thinking that was better for you. What research is starting to show us is, in fact, that may not be true. So in the milk study, whole milk or non-fat milk would be the independent variable that we've manipulated, and I would give participants different amounts of milk to consume, and then the dependent variable is the measurement of health that I'm looking at, like rates of obesity or heart disease. But remember, the researcher has to manipulate it. If I were to just go out and to ask people, what do you drink? Are you drinking whole fat milk or low fat milk or non-fat milk? And then I measure to see if there's a correlation between their milk consumption and their heart disease. That is a correlational study, right? So that's a predictive study from our second goal of science. So remember, in an experiment, you actually have to do a manipulation. One of the things about experiments is that they can determine cause and effect relationships. And there are three things that must happen in order to determine cause and effect relationships. One, the two variables or the two events, whatever we're measuring, they have to correlate or co-vary together, right? So there has to already be a correlation, for example, between the kind of milk you consume and your health. But then also the causal event has to actually occur before the effect that I'm interested in. So if your rate of obesity was already low prior to the study looking at the kind of milk you consumed, then that in fact actually doesn't meet that second requirement, right? So what should happen is you should be consuming whole milk or non-fat milk in the study, and then your health should change, right? It should get better for those drinking one version versus another. In addition, though, the third, and one that we're going to spend more time in chapter 10 talking about, is that we have to have ruled out or controlled the environment so that we can rule out alternative explanations. This is actually what you do by taking track and keeping careful control of internal validity. Internal validity is that you've developed an experiment that is so well controlled that you've ruled out all possible explanations. You might imagine there are so many things in your diet and in your lifestyle that could affect your rate of heart disease or obesity. Your exercise habits, your soda consumption, your saturated fat consumption, the number of calories you consume, that may be totally separate from the amount of milk or the kind of milk you're consuming. So in my milk study, I would need to make sure that I have everyone consuming the same total number of calories. Remember, whole milk is going to have more calories though. So you're going to have to somehow increase the calories of the other participants who are drinking the non-fat or low-fat milk, right? Because you want to make sure it's not a calorie effect. You want to make sure that they're exercising the same. You want to make sure that in general they're eating the same kinds of foods. You can imagine how difficult that is in practice, right? In human studies, it is really difficult to maintain great internal validity because humans often don't want that degree of control over their eating habits and exercise habits, for example. And that, in fact, is one of the reasons why we really do rely on animal research, because animal research allows us to look at the causes of behavior, and we can control the diet down to that level. Okay. So now let's practice trying to determine the different kinds of claims. So remember that there are three kinds of claims: frequency claims, association claims, and causal claims. Frequency claims are ones about frequency, rate, number. So they usually just have a single variable. Association claims are really about the correlation between two variables. So they will tend to use verbs like linked, higher risk, lower risk, associated, correlated, more or less likely, predicts, tied, goes with. Those are some example verbs that you'll see in association claims. Causal claims, on the other hand, that you might see in a newspaper headline, will include words that you can see here: causes, affects, promotes, reduces, prevents, blocks, changes, hurts, increases. All of those are some examples. So when you're looking at newspaper headlines, you should be able to look at them and judge whether they're making frequency claims about a certain percentage of individuals, whether they're making association claims, or whether they're making causal claims, where they did maybe an experiment. So let's take a look. I have 13 examples of claims that are either frequency claims, association claims, or causal claims. Okay. Now you can see here, worry may make women's brains work overtime. OMG, texting and IMing not linked to spelling. So look at these on a piece of paper. You do not have to turn this in, but I do want you to actually practice because you're going to have to do this on a homework assignment. So I want you to pause the video here and identify which of these are frequency claims, whether just about rate or number, which are association claims, using those verbs that you just saw, and you can rewind if you need to, or are they causal claims? Pause the video here. Okay, now let's take a look. So when I look through these 13, there are two that I see to be frequency claims. So frequency claims are number 8 and 11. Report 16% of teens have considered suicide. That is just a rate or a percent of teens, okay? It's not a saying teens who watched this certain show have considered suicide, right? Which would be an association claim. Breastfeeding rates hit new high in the United States, also a frequency claim, okay? What about the association claims though? Which ones did you identify? So for me, I have number 2, number 6, and number 12. Number 2 uses the verb linked, or in this case, not linked to spelling. Number 6 uses the word associated. And number 12 uses at risk for worse grades. So at risk or risk of worse grades is a association claim. Okay? So those 3 are all associations, which means the remainder of them are causal claims. On the homework assignment for this week, you're going to look at those claims and identify, in this case, whether they are association or causal claims. And then you're going to pick one of those, and you're actually going to dig into one of the articles, and you're going to write up your description. Is it an association claim? Is it an association study? Did they just measure the correlations between two variables? More typically, I think what you're going to find is that they are making causal claims in the headline, but in fact the research was probably a correlational study where they, like with milk, they just measured the number of people consuming high-fat or low-fat milk, and then they correlate that with the rate of obesity. To make a causal claim, you should have an experiment, right, where you've actually done a manipulation, where I've made people drink a certain kind of milk for a year or 5 years or some other amount of time, and then measured to see what happens after the fact. And I've ruled out other possible explanations, like general caloric consumption. Okay. Lastly, what we're going to talk about is the fourth goal of science. The fourth goal of science is the one that you're probably most interested in, and it's the one that people most think about when we talk about psychology. The fourth goal of science is application, that we use knowledge to actually alter the human condition, that we're looking at the benefits of marital counseling or educational attainment, and what we can do to help boost students' educational attainment. We're using research on eyewitness testimony to improve how detectives and people involved in law enforcement interview eyewitnesses, right, using cognitive interviewing techniques. In addition, right, we're using drug therapies to try to improve the lives of people, both in psychological and in medical conditions. One of the things about, remember in the very first goal of science, we talked about the nomothetic approach. And the nomothetic approach, remember, is trying to make broad generalizations about a large group of people or population. In application, though, you're really not going to use only the nomothetic approach. We can also use the idiographic approach, which is where we try to understand and assist a single individual. And this is often the difference between what researchers are doing, which is trying to understand as many people as possible, whereas clinicians like psychologists or doctors or nurses are really trying to do the things that are going to help that particular individual, right? And it's tailored to that particular person's needs rather than what's effective for 90% of the population or 70% of the population. Okay, hopefully that gets you started. I will post the remaining lectures on Thursday, so let me know if you have any questions.